Yeah, welcome to my case file session. I've done those a couple of times in the past at various Shark Fests, and it's usually something where I just present a couple of interesting cases that I had during my normal daily routines of working on whatever problems the customers have. And since for quite some time now, I'm focusing more on security. So you will notice that there's a slight, way of going into security topics in this one. I also did not have much time to prepare because I got a bit sick and had to recover from it. So no, it wasn't COVID, but we'll see how we go. All right, so let's see. First things first. Well, I just said I'm Jasper Bongertz. I'm here because I love analyzing packets, and you can find me at PackageA on Twitter if you want to. If you don't want to, that's fine too. I have a couple of cases for you, 3. And before we go into that, well, maybe I should tell you now that my current day job is working for a more or less small company in Germany, mostly doing incident response, which means that when customers get attacked by hackers or have any kind of security incident, they usually need somebody to help them because that is not what their daily operation is meant to handle. And very often what we get at the company I work for, which is G-Data Advanced Analytics, are ransomware cases. And since I'm one of the people or guys, persons, women, whatever, that go out to the customer side to help them, I see a lot of those in my time. I had a couple of big cases in the past, and 1 or 2 of them we will take a look at here and see what Wireshark can do to help us. And the first thing is something that is about 2 years ago, I think. I call this case a beachhead case. It is a ransomware victim in this situation. And now the problem is they called us and told us everything is encrypted completely. There's no way to stop any encryption activity from going on, which sometimes happens. Sometimes companies notice that the encryption started and can do something to prevent it, for example, shutting down servers, or what most of them do is actually disconnect their internet connection to take away the control that the attackers have over the network. Because if you're not connected to the internet, usually the attackers from the outside world cannot do anything anymore in your network. But you still, of course, have sometimes stuff still running in your network, which means shutting down the servers and cutting the internet connection is usually a pretty good idea in a ransomware case. There are other cases of cyber attacks where it's not such a good idea to cut the internet connection, because sometimes you don't want the attackers to know that you spotted them or that you suspect that they are there, in which cases you should not disconnect your internet connection. But this is something that needs to be decided by case. And in this case, they called us and they told us everything is encrypted, the encryption is completely gone through, and we haven't disconnected the internet connection. Should we disconnect the internet connection? Well, in this case, we said it's probably a good idea not to disconnect the internet, because then we can take a look and see if we can find anything that they're doing. Because if they can't do much more damage to the data, because it had been completely damaged already, then maybe we can take a look if they have some kind of beachhead or, well, any kind of callback or other things they're communicating still with. And this might sound a bit puzzling because I just said they encrypted everything. What the attacker groups usually do is they leave everything intact that you need to communicate with them and let them have bitcoins, which means usually they don't take down your Active Directory infrastructure, which, by the way, doesn't mean that you need to completely do it from scratch, because when an attacker has taken over your Active Directory, and they usually do, you need to recover it. And recovering it means basically building it from scratch. So in this case, the Active Directory was still online, and I think a couple of not so important servers were also still running, but everything else was encrypted. And that was really tough for the company because they didn't have backups anymore, because the backups were deleted first. The attackers did that by finding the storage system that was used to backup stuff, and they initialized it to factory default, wiping everything off it, which couldn't be recovered anymore. So no backups, nothing anymore. So what we were trying to find out in the beginning of this, before starting to do everything that is required to get the company back online, is see if there's an attacker still in the network. And how do we do that? Well, we install a sniffer, usually at the perimeter firewall. And if you take a look at this very simple diagram here, to the right of the diagram with the internal network switch, of course, there's a lot more than just one switch. It's a company like with about 1,000 employees, I think. So there's much more technology on the inside of the network. I just left that out because it's not relevant that much. But if you're into security a little bit, and even if not, one thing should be puzzling you or frightening you here in this picture, because there's only one firewall. They didn't have a second firewall between them and the internet, which you usually do if you expose anything to the internet, like having an outer firewall and an inner firewall with a DMZ, demilitarized zone in between. They didn't have that. So what I did is I put in a full duplex tab, 1 gigabit copper, and hooked up a sniffer and captured everything that was going on. It was a gigabit line. So yeah, there was not much going on that link. Usually they have like, I think about 600 megabits of traffic on that link. But since everything was shut down on the inside of the network, or almost everything, there was not much going on. And capturing where not much is going on is actually quite nice, because then it's easier to find stuff that you want to look at. So this way I captured the data and then I pulled it off the sniffer. Notice here that I'm not doing a span port. I'm also not capturing on any system involved, especially not on the firewall, because in a situation like this, at the beginning, you never know what you can trust. So it could be possible that the firewall is compromised, that the switches are compromised, that everything is compromised, and that the attackers have found a way to hide their communication from me. Because theoretically, and I say that in, well, quotation marks, because it doesn't happen that often, really, they could actually try to hide the communication from you, which normally it doesn't happen. But it's a good idea to use a tab, because the tab is your device. It's completely passive from a network point of view. It's not completely passive from an electrical point of view, but forget about that. But if you put a tab in like this, a copper tab is quite good. A fiber tab would be better. The attackers have no way of hiding their packets. They have to go through that device. And if they go through that device, they get forwarded to my sniffer. And there I can capture them. They have no way of hiding their communication if I put in a tab like this. The only drawback here is you need to be sure that this is the only internet connection that the company has. If they have more than one, well, sometimes in different branches or something like this, and they're all interconnected, then you need to think about where to put what. But in this case, they had only one, and I put the tab in there. So let's see if I have the trace file here. Where is it? I need to find my Wireshark. Yeah, I have too many Wiresharks everywhere. Beachhead anonymized. There it is. So it looks like this. And I know that the font is too small. I will make it bigger. I hope this is okay like this. And of course, it's anonymized because, well, you wouldn't want me to show your compromised traffic if you got hit by a ransomware attack, right? So anyway, this is some of the traffic that I captured. I captured a lot more. I think over the whole case, I captured about 8 terabytes of data in total, because we also often capture during the recovery and reestablishment phase, or the build-up of the network, to check if everything is there and nothing is there that shouldn't be, always keeping an eye on things. And if you look through this, there's a lot of packets, and scrolling through packets sometimes is helpful, sometimes it's not. But in this case, looking for things like retransmissions and other, let's say, performance errors is not my problem. What I want to know is there an attacker in here somewhere? And what you can also see in some cases here is that there are destination unreachables, like a lot of them. And they would also be interesting in a performance troubleshooting, but not so much in this case, because we know they shut down all their servers. So a lot of communication is trying to reach the servers, because the internet is still online, and can't get there. So you get destination unreachables, and you also get destination unreachables in the other direction. For some reason, that's how it is. So how can we find if there's an attacker? And what attackers usually do, and that is the kind of knowledge that you probably need to have, is if they're in your network, they often create something like a callback mechanism. That means that they're pinging one server of their own in the internet to get new commands and receive anything that the attacker wants to do in the network. And that is like command and control traffic, so to speak. And command and control traffic is often, if the attacker is not very, very careful hiding it, very easy to find. And we can take a look at, for example, the statistics here. Look at conversations. And we see there's a lot of conversations here. And a lot of them are going from the same address to the same other address. But is that enough to be a command and control? Well, in this case, Wireshark is maybe quite okay to do this and take a look at it. But what I did in this case is I actually used my own tool, which is Trace Wrangler. I don't know if you've seen Trace Wrangler. It's used by almost all the presenters now, I think, to sanitize their traces. But I also use it a lot to work on great amounts of data, because it's often complicated to load more than a couple of gigabytes into Wireshark. And even loading gigabytes into Wireshark is not fun at all. So if I add this file to my own tool, it will scan it completely and extract a lot of details that I can take a look at. And now I have a tool here that is called Endpoints and Conversations. And if I open that, I go to the IP address range. This looks familiar, right? It's like the conversation summary in the background from Wireshark. And what I have here is a column, and this is really small, so let's see if I can zoom in. That is actually telling me how many flows there are between two IP addresses. And I can sort it, and you can see here that there's 14,030 flows between these two IP addresses. And that is quite a lot if you consider that this is a, I think, 20-minute capture or something. Let me check. I think in the statistics, we can see that the total duration is just 20 minutes. You can see it here, 20 minutes. And in those 20 minutes, there were 14,000 connections from one IP to one of our own. And that is quite a lot. No, I needed to look at the conversations. I was in the wrong tab. That was addresses. I wanted the conversations, but still, that is the same thing. I can also see here the flows. It's only 9,000, but still in 20 minutes, and there it is, 20 minutes duration, 9,314 flows. Yeah, that is quite a lot, right? So when we look at this conversation, and what I can do here is, if I select this, I can copy a filter in Wireshark syntax for this thing and insert it here. It takes a while because we have about 500,000 packets. Then you can see that there's a lot of conversations going on. And it's always like, if I colorize it, not very long. It's syn, synac, ec, which is a handshake. Then there's some push, ec, push, ec, push, ec, push, ec, and so on. Fin, ec, fin, ec. So this looks like, well, there's something going on, but we don't know exactly what. But I had the advantage of course, I wasn't working with a sanitized trace, right? So I was able to look at the payload. And you can see from the port 443 that this is supposedly HTTPS. So in the beginning of an encrypted HTTP communication over HTTPS, you have this whole certificate handshake kind of thing, TLS handshake, client hello, server hello. A lot of packets in the beginning are just for the handshake. And I had to remove them because Tracehanger so far is not capable of sanitizing that in a way that is useful. So all this information is missing here, but let me tell you that in there you had a crypto handshake, so to speak, but not a normal one from HTTPS like you would see from a website. It was more like a self-written TLS protocol thing. It was using a correct crypto, but it was not doing anything like a web browser would. And it did that over and over and over again. You can see here in the delta times between this conversation, the colored one, and the next one, there's only 77 milliseconds until it tries again. Now let's colorize that one. And when that's over, it waits for almost 100 milliseconds. And then it waits for, there's a little bit of interleaving here, but it's really like firing quickly. And it's always doing the same thing. It is connecting with a TCP handshake, it's doing the crypto exchange, and then nothing happens and it closes the connection again. Then it starts the connection again, does the crypto exchange, nothing happens, it closes the connection again. And it does this in 20 minutes over 9,000 times. So it's quite obvious that this is like the callback that the attackers are using. And well, we didn't see anything in there where they were still actively trying to do anything. Like we didn't see any kind of larger payloads going back and forth. So as far as we can tell, they just had this lifeline still going while they were waiting for the ransom money. And unfortunately, since the company had no backups anymore and had no tapes and no other offline backups, they had to pay the ransom, which you normally should try to avoid, but they had to, and they got the decryption tool, luckily, and it worked, which is also very lucky because sometimes they don't. And at that same point in time where the payment was made, this communication stopped and you couldn't see it anymore. So the attackers kept it going until the exact point in time until the ransom was paid, and then they left them alone. By the way, they sent them an email telling them where their security issues were and what they needed to fix so that it wouldn't happen again, like a sort of service to the victim that already had found out that it was not as well protected as it should have been. So this is a case where we could find one of these callbacks. It only showed us that they're still in there. We kept monitoring them. We saw that they were not doing anything else. But of course, it stopped when the ransom was paid, and of course, everything was built from scratch. And this company has spent 1.5 years by now rebuilding everything in a much better way, spending much more focus on security and much more network segregation. A lot of my customers who have this kind of problem, they tell me, hey, we have VLANs and everything is segmented. And then you ask them like, okay, you have them, but is there a firewall in between them? And they usually tell you no, because everything must be able to connect to everything, because they don't want any troubles with something not connecting to the other thing. And that means that if an attacker gains access to your network, it doesn't matter which part of the network it is, it can go anywhere. And usually after you pay a ransom, you find out that it would be a good idea to have an internal firewall that separates all these nice VLANs that you have, so that only the communication that you really need goes through. And this is one of the 2 key points that you probably can take away for your own company if you don't have it yet. Have offline backups, because the online ones will be found and they will be destroyed. We have seen attackers reverse engineering self-written backup software until they understood it and could destroy it. So have offline backups, tapes, and I don't care, disks that you put into a safe somewhere, and segment your networks. Have firewalls in place and actually use them. All right, so that was that one. This can go away. I don't need tracing anymore. And let me check if there's a question. There are questions. Okay, Jim Young is asking, are you worried about session drops or state teardown while inserting the tab? In normal operations, it is a minor concern because I'm pretty quick inserting a tab. I can usually do it with a link state down of about 3 seconds. If I prepare myself, it's like a really quick shove of the cable. But in normal operations, of course, you would get like a small maintenance window for this kind of thing. But in a ransomware case where you have all the servers shut down anyway, it doesn't really matter. You can take half an hour to put a tab in if you want to, because nobody cares. It's just you have the time. Okay, how do you manage capturing terabytes of data? Do you use Packet Broker? What equipment or capturing do you use? Commercial sniffing, etc. What I use is, of course, I use commercial tabs because building your own tab is not possible anymore if you're running gigabits or higher, because the self-built ones that everybody had only work for 100 megabit and below. Because of the way gigabit works. Gigabit has only 4 cables that it communicates with, or no, it has 8 cables. It has 4 times 250 megabits per second, which is a gigabit, but it needs to do that full duplex, so the 2 signals are on top of each other. And that means that only the endpoints know when the signal is sent or not sent, and something in between that is completely passive can't, at least not for copper. So you need to buy tabs actually. And the sniffer that I use is a self-built sniffer, but it has a commercial FPGA-based capture card. So this PC is a very small shoebox kind of thing. It's very portable. It's like this big. And the card in there is probably 5 times as expensive as the rest of the device, because these FPGA capture cards they're just expensive, but they don't drop packets. And if you need to capture everything, and in this case I needed to, this is the good way to go. Okay, how did the certificates look like? Yeah, I think they were self-signed. I don't remember because it's almost 2 years ago. We just looked at it and we saw like, this is not normal. This is something somebody built like on their own a certificate authority or something. I think it was something bogus. I'm not sure. I can't remember. Okay, you should secure your servers client machines. Yes, you should. Inserting the tab sounds like a competition for the next in-person shark list. Who can insert the tab the smoothest way without losing the most connections? Actually, we could we could make something out of that. Yes, that would be a fun thing to have. Okay, if there's no more questions, I continue to the next one. And guess what? My mouse pointer is somewhere else. There it is. It is a ransomware victim. Yes, another. I get a lot of those. And in this case, they were able to recover from backups, which is good because they didn't have to pay. The problem here is, well, not the problem, but in this case, they tore down the internet connection. We checked all the servers. I have colleagues who can check servers like in a record time. We have reverse engineers that can pull apart malware and see what it does. So in this case, all of that was handled, but what they had, or what we didn't have, was the initial point of entry. So we didn't know, how did the attackers actually get into the network? And to this day, I think we don't know how they did that, which is a bad feeling, because in an attack like this, you usually want to know, how did that happen, so that you can fix it for the next time. What we suspected, or what I suspected, or what at least I suggested, is they have one application that is used to order their goods, like an order entry system. It was self-written, of course. It was a web application, and self-written web applications in a small to medium-sized company, I think they had also around 800 employees, so to speak. Self-written applications in that size usually mean that nobody cares about security in those applications. And it's a pen tester's dream to work on an application like this, because they usually find all kinds of problems with it, like SQL injection and cross-site scripting and whatnot. So they had this application and they needed it to run as soon as possible, because if it doesn't run, nobody can order their goods. And that means if they don't do that, or if that application is running for, let's say, a week or two, they are probably in a financial situation that threatens the survival of the company. So it needed to go online again. We couldn't fix, or we couldn't have an audit that quickly on that application, of course, because it's not that easy to do that just on the spot. So what they did was they put a web application firewall in front of it, and put in a good set of rules to allow only calls that make sense to them. So they defined a policy that said only these kind of calls with these parameters are okay. And the parameters are not really complicated, so it's not like rocket science to do that. They should have done that before. They didn't, but now they do. So the question was, is that still good enough? And so the task was to verify, are there any calls getting through that firewall that shouldn't? And that meant that we needed to capture again and check the traffic for all these communications and see if only the allowed parameters are, or calls are, seen. Here's their setup. At least they had two firewalls. In this case, they had the parameter firewall and the web application firewall. Well, they had that after the fact. So it's basically like the first case. And the sniffer was placed between the web application firewall and the web application itself. Actually, this was kind of a bit of a issue, because both the web application firewall and the web application were virtual machines. So in this case, I had to capture on a virtual machine inside their virtual infrastructure using a distributed switch and using a span port on this virtual switch and getting all the packets. This one is, that was the advantage. They had the highest VMware license, I think, where you can have the distributed switches with the span port feature. And so we could just span the traffic to a virtual machine. If you do that, like capturing to a virtual machine, you need to make sure that this virtual machine is on storage that is fast enough, and it should be on dedicated storage, because otherwise it could drastically reduce the performance of the other machines on that storage. So That setup, of course, I had to do that because in that company, nobody knew how to do a setup like this, which is quite typical. But let's take a look at the trace. So there are a couple of files I captured for a long time. So usually I do a capture that writes like a couple of 100 megabytes or something per file. And now my task was every once in a while to check if all the parameters, all the calls are correct, or if there's anything that shouldn't have gotten through this web application firewall. So as an example, I can show you packet number 65, I think it was. That's how it looked like. And there's this HTTP call in here. You can see I sanitized this one with Trace Wrangler. It doesn't sanitize HTTP yet, so I had to do string replacements, which was quite time consuming. But in the end, this SOAP action is the thing that I needed to look for. That is the interesting thing. This is the one where I needed to make sure that only the calls that are allowed get through. In this case, you can see the call here is the test call. It's just called tests for, I don't know what it does, but that was one of the valid ones. So there's also an authorization in here. I replaced it with SharkFest because sometimes people in those presentations grab this string and they know it's based on 64 encoder and revert it. So I had to replace it too. And now the question is, how can we get all these SOAP action calls and verify them? So my first idea was, hey, this is not that complicated. We can just go and make a column for this one. So as you probably know, you can create custom columns with any kind of info from any field in the decode you want. For example, if you want to have a, let's say, content length column, you could right click and say apply as column. And then you need to realign your column sizes. And then you can see when there's a packet that has this value, it's in this column. So I don't need this one. What I need is I need a SOAP action column. So what I did is I clicked apply as column, or also what is possible is you just drag and drop it here. Let's say I want it here. Now it's ended up here. The problem is you can see my SOAP action is in there, but that's not the only thing that's in there. And the problem here is that this SOAP action is, if you can see the filter for it, it's http.request.line, which is a generic field. So it's just a text field in the HTTP header where Wireshark doesn't know what it is. So the SOAP action is something that it doesn't know. So I can't create a column that only contains it or hold it, which is a problem because I only want to see this one and I don't want to see the user agent, because you can see here, it has the same request line. It also says HTTP request line if I click on that, right? The header has its own, but the user agent is HTTP. No, I get myself into trouble here again. Well, anyway, HTTP request line is not good enough. So what I need to do is I need to tell Wireshark, hey, this SOAP action is a field that I need. And if you have seen Uli's talk on the first day, which is, I think, was yesterday, then you know, or probably know, or maybe know that you can do that. So we can go into the preferences, protocols, look for HTTP, and you have something here called custom HTTP header fields. So what I do here is I add a custom field called, what's it called? The name was SOAP action. It must be written the same exact same way, SOAP action. SOAP action, like this. And I give it a name, SOAP action. Okay. Okay. And then Wireshark has to reprocess all the packets because now I told it to give me a specific field for this SOAP action. And now I have a HTTP header SOAP action field. So now I can do the same thing again, move it up here. Maybe this works the way I want it to. Yeah, there it is. And now only my call is in there. The only thing that I need, really. So the annoying part here now is that I don't want to basically load all of the files one after one to check all these SOAP action calls and see if there's anything in there. For example, especially since I would now need to look at all of them and compare them to my list and say, this is a valid one, this is not a valid one. So in this case, what I do, and most people usually do as soon as they know that this is an option, is we go to the command line and do that on the command line instead, because doing that in the GUI is too much work. And we're basically, well, lazy. Analysts need to be lazy because otherwise it takes way too long to process everything. So let's take a look. We're in the defense one, and you can see here I have a couple of files, not just one. So what I do now is I use T-Shark, and I use T-Shark to read, let's say, the first one, and I want to have a field extraction, and my field is called http.header.SOAP action. Let's see if this works. This is not valid. Why isn't it valid? The problem here is that T-Shark uses the default profile. And for this talk, I'm using my demo profile. So I need to tell T-Shark, hey, please use my demo profile, because only in the demo profile I have this field defined. In the default one, it's not defined. So it doesn't know what HTTP header SOAP action is supposed to be. So I need to give it the profile name of the profile where I put in this extra field that I just configured in Wireshark, which is why you need to go into Wireshark sometimes to do this before you can run something on the command line. So this should work now. Yeah, good. So this is nice, but well, I need to do that for all the files. And to do that, what I can do is for %a, which is a variable, in star.pcapng do. So that means read all the pcapng files. And now of course, I give it %a so that it reads the file of the current name and output the stuff. So there's still a lot of empty lines because not all packets have this field, obviously. So what I need to do here is I could tell it to say I want a filter http.method so that I at least only get what's the name of this damn thing? I just want the post fields, so I need request method. Okay, sorry. The day is too long. Request method. http.request.method. Yeah, whatever. Okay, nice. This looks better. So you can see that a lot of calls are repeating themselves. So what I usually do here is now pipe that into sort, which is a Unix tool, which I download from SourceForge usually, and unique, so that it gets sorted and then it gets uniqued, and I can add a counter so that it counts for me how often it found the communication or the parameters. And now we wait until it's done. And I only used 6 files here, so it should be relatively fast. And there it is. Why? Oh, I pressed enter again. So you can see here, I have this number of calls, and now I can easily just check, hey, this is a valid one, this is a valid one, this is a valid one. Basically what the application people can tell me what the valid calls are. And well, I can just compare them and check, okay, is there anything in there that I don't know? Then I have a problem. But it turned out that every single time I ran this, and I did that for a couple of days, just running this script all over again, all the time on the new files each time, I could just get the list that it gave me and compare that to the list of commands that were allowed. And after like 2 weeks or so, we were quite sure that the web application firewall did what it should be. What we could have done is actually capture in front of it to see if anybody's trying to do funny things with it. We didn't do that, but we could have done that to compare if the inner side and the outer side actually are different. But this is how the HTTP header field, the custom field, is really useful, because it saves a lot of time being able to run it this way. All right, so let's see, what do we have from questions? There's one from Miroslav. What are you using to store terabytes of data in customers' location, some kind of NAS? Yes, sometimes we use a NAS if it's really getting big. So if we have like 2-digit numbers of terabytes, up to, I think the largest disks that I have right now, single disk, are 12 or 14 terabytes. And I usually copy the data from the device in the night when there's not much traffic. So you can also do it with just USB connected hard drives. It should be USB 3 actually, because otherwise it takes too long. And it would be nice to have SSDs for that, but they're too expensive. So what I usually do is have like Western Digital Black or something that are really fast, and copy that data just to the external disks. If it's really a lot of traffic, we can also do that to a NAS that we have. Okay. Okay, that is not a question. Apply as a column is a very neat feature. Yes, it is. Do you use Windows a lot for analysis because that's what customers have? Actually, no. I use Windows because I'm not really good at Unix and Linux. And a lot of my tools that I know how to use are on Windows. And I'm just a Windows person. I'm only, I think, we have a handful. I mean, I have about 35 coworkers, I think, and all of them use Linux, and only 3 or 4 of us use Windows. But everybody uses what he ever wants. If it works, if it gets the job done, it's fine. So I'm used to Windows. I know how to use it. I can troubleshoot it. I can write my own programs on it. Tracing is on Windows. I would have to run it in a VM all the time, which would totally annoy me and probably force me to learn C and write it again. So Sake is now probably asking me to change to Linux. Yeah, it's just, I'm just using Windows. Okay, anything else? No? Okay, so we have 14 minutes left. Jim has a little info that you can sort -NR to get the top list. Yeah, that is helpful. But I needed the complete list. So in this case, it's just sort unique. All right, this can go too. And I still have one question coming from Miroslav. What is your best practice to do analysis on multiple monitors? Like, what is on which monitor? I have right now, I think 1, 2, 3, 4, 5 monitors. There's a 6th one for my office laptop. What I usually do is I have the Wiresharks on my center monitor and the right one, and I have like RFCs and other information to the left. But it's totally up to you. The 4th one is up there, so it's up there in the corner, that is only for status and something. Right now, if you could see it, it is running a giant clock telling me I have 13 minutes and 35 seconds left. So it's just for the smaller things. So just set it up the way you like to. I like Wireshark in the center because I need to look at it, and it should be a good monitor because you're staring on a lot of small characters all the time. Okay, last one. Case number 3. This is called Seriously. And this is not a ransomware case, fortunately, because I have too many of those. This is something where I was asked to help with an analysis because nobody had an idea what was going on. This concerned a virtualization environment on 2 data centers. Those data centers were connected with a 10G fiber link or a 10G link, whatever. There was a service provider doing that for them. And the distance between them was about 600 kilometers. So it was quite far away. And what they wanted to do is they wanted to move their virtual machines from one data center to the other data center. And they got to, I think, a speed of something like 25 megabytes per second or something, really slow. It was like agonizingly slow. And they wanted to know what was going on. So what they did is they called somebody to check the link of the service provider end to end. So they connected a device on their one end and their other end, and basically a traffic generator generating traffic. And they found out the link worked just fine. They got the full 10 gigabit, so it must be something else. And that was when I was brought in to help with the analysis. And before you can do an analysis, the first thing you need to do is capture. And capturing this was, I think, the biggest environment I've seen so far from a throughput point of view, because this is how it looked like. It was more complex than this. I removed a couple of things, and well, they had, like in the new data center, which is the upper one, they had up to 100 gigabit. They had, I think, 40 gigabit in the lower one, and we needed to capture simultaneously to see where the problem might be. So what we finally decided on, and this capture point 1 here is annoying, but it's not capture point 1. This is capture point 4. We decided to capture on this infrastructure with a real big, well, yeah, a big load of hardware that we carried in there, like packet brokers and really fast capture machines. With the equipment was like insanely expensive. And we put one on each side right just before the provider connections. So capture point 3 here is, no, capture point 3 is right before the provider device. And capture point 2 was moved here for some reason I can't remember, but all those switches were not that relevant anymore, or didn't add so much to the whole thing of this. So we had 2 capture points down here and 2 capture points up here, and then we could capture a, well, machine transfer from one to the other. And you can imagine this capture file gets quite big, so this will be very slow when I show it to you. And I only chose to do this because this is probably something that I can only do on this machine here, and not on a laptop when I travel to SharkFest. And I hope I will be able to travel to SharkFest again and see all of you people instead of talking to my monitor, which is quite annoying. So here I can load it in my Wireshark and show it to you without having to wait for half an hour or something. So what I want to do is remove that PowerPoint. I have preloaded the trace so that it gets a little bit faster. And resize the columns. And you can see in the statistics. That this is, I think, a throughput of 25 megabytes. And that is not good enough for the customer, actually. So they wanted more, and I can imagine they wanted more. So what we did is capture on all 4 points at the same time. And then I got these captures. And the first thing, if you get a multi-point capture like this, is you need to find out if there are differences between them. And if you remember how this case is called, it's called seriously. I looked at the first trace file, like this one, and I wanted to see if there's any kind of packet loss, retransmission, out of order, all these things that you would expect from a thing like this. Because, I mean, this is a 600 kilometer distance. There's a lot of traffic going on. And this trace file from capture point 1, and I can show you the PowerPoint again. Capture point 1 is actually not here, it's down here. This capture point had 0 packet loss, 0 retransmissions, and 0 out of order packets. Not a single one. And I have never seen that before. Usually you always have some sort of packet race going wrong, and the first arrives before the second, and some packets get lost and whatever. Not a single packet lost on capture point 1. So I checked the other capture points, and it was exactly the same. There was not a single packet lost anywhere, not a single packet out of order anywhere, and not a retransmission anywhere. And I'm not sure how that works, but it just did. So that basically means that when you're looking at the trace, you are not looking for packet loss, and you're not looking for any kind of funny out of order, whatever kind of problem. But what you need to do is you need to look at what are the machines actually doing from a timing perspective. And for that, I have already started to open the sequence numbers graph, the TCP trace one, from statistics, TCP stream graphs, and time sequence TCP trace, because it loads forever still. And you need to zoom in really quite a bit. And I will show you the zoomed out graph afterwards, because it's very interesting too. But if you zoom in to this graph, and you can maybe already see it, the green thin line is the window size, the available window size. And this is the ceiling of how much data the sender can send. So if it's basically sending at full speed, it should try to get as much data across as possible. And what you can see here is that for some reason, the sender keeps waiting and waiting and never reaching the ceiling completely. And maybe that's also because it's not act fast enough, but there's a lot of room, and it's not hitting like a window full or something. There's always space to go on, but it doesn't. And it's probably because it has some problems with getting the data to be sent, or the acknowledgements only trickle in a certain pattern. And I have to admit, it's so long ago that I can't remember what exactly it was. I think if I remember from the report that I wrote, is that in the end, the sending machine was stopping for some reason and not continuing. And when we opened the case with VMware, which was the vendor of this thing, they told us that they had already found this issue and fixed it in a later release of the hypervisor. And that was how the customer basically got his full speed back. I don't know if it was at full 10 gig, but it was nice and fast. So basically, that was a problem in the hypervisor where it didn't actually speed up and use the full potential of the conversation of the link. By the way, this is how the graph looks like. I want to zoom in again. Why doesn't it let me zoom in? Come on. I probably moved the mouse wheel too much. If you can see it, this is like a typical line when you have sequence number wrapping, because it was a 10 gigabit file. And of course, it wraps a couple of times. So it goes up to the ceiling and then it comes down and starts from the bottom again. So this is quite a funny thing as well. All right, so I wanted to show you this one mostly because I have never seen a trace where you have no, especially at those speeds and those distances, you have no out of orders and no retransmissions and no packet loss. That was just, I was sitting there for like 5 minutes thinking, what did we do wrong? This is too perfect. But it was basically just not the network. It often is not the network in 80% of the cases. But this was, yeah, totally clear. It's not the network. All right, so let's see. Do we have some questions here? Sorry for this noob question. Where could I found this session for replay? That is not a noob question. We always put the sessions or the recordings of the session on the retrospective page. So you can find it on YouTube and on the retrospective page. Could sequence number wrapping be an issue if you don't use TCP timestamps? Yes, it could be, but most modern stacks are now able to deal with that kind of thing. I have not seen an issue with that recently, but I have to admit that I haven't looked at many performance things in the couple of months, because I'm more or less helping people get rid of ransomware now. So this is like a totally different thing. You're not doing performance troubleshooting that much if you're helping people to recover their data and beat the bad guys. Okay, did you capture a post VMware fixed transfer? No, because I think it took a while for them to implement it, and they weren't interested in that kind of thing because it worked apparently, and then they were like, yeah, it works, it's fine. Okay, how often is the IF column needed? The IF column is this one here. And I can align center. This is the interface number, right? So it tells me interface ID 0. And usually if you have a capture where there's only one network interface that was used to capture you, it's always 0. But because it's very small, I have it, it's intentional to call it IF, so it doesn't take much screen space, because screen space is very valuable if you have Wireshark. And the number itself, it's just the number between 1 and 3 usually. I use it sometimes to see if the capture was taking more than one interface, because if it is, there's a whole lot of problems that often occur because people are not always using good FPGA cards. They're using more than one card and combining the traces afterwards, and that gets it into trouble if you're analyzing. So it's nice to have, because if there's always a 0, that just tells me it's just one interface and I don't need to worry about out of order, time out of order packets and stuff like this. Okay, any more questions? Because my timer tells me my session is basically done. I hope you had some fun. I hope you saw a couple of things that were maybe new to you and useful. If you take anything away from this, please don't get hit by ransomware, because if you see me coming into your company, that usually means that something went really wrong, and that is not a good day to have. Okay, Matthias Kaiser asked, after having the VM fixed, were there any retransmissions then? I don't know, because I didn't capture after analyzing this one, so I'm not sure. Probably as soon as you start really sending more data and maxing out the connections, I would expect to see packet drops. Yes. All right. So, any more questions? If you don't want to ask now, if you want to ask later, or if you want to talk to me directly, just do that on Discord. I will be there. Other than that, thank you for watching. Thank you for listening. Thank you for staying with me this long. And I hope you had some fun. All right. Thanks and bye-bye.